Okay, let's look at programming the board and a little bit more detail about the actual registers. So first off, let's talk about the transmission for the UARTs. And we'll talk about these in sort of a linear fashion, and then we'll actually talk about the receiving and then look at those particular registers. So first it says program the M bits in the CR1 register for the USR. That will define the word length. Then we have to select the desired baud rate using the BRR register. We already talked about how you need to go about that process using that formula. That also includes if you're doing oversampling and all that sort of stuff. That's how you have to decide on the BRR value. We'll end up this talking about a slide that shows basically for a 72 megahertz clock what those values for BRR need to be to get certain baud rates. Then we have to program the number of stop bits. That's in the CR2 register of the UART. Then we have to begin transmitting by first enabling the USART enable bit in the CR1 register. Then we have to set the transmit enable bit, because if we're doing transmission we have to set that. And then we have to send an idle frame as the first transmission here. Then we have to write the data that we want to send, and where do we put that? We put that in the transmit data register, the TDR register. When we do that, you can see this will clear the transmit enable bit, and each time we want to do that, each time we want to send something, we have to put something new in the transmit data register, and it will send it out. It says after writing the last data into the transmit data register, so after we've done all of our sending, then we have to wait until this TC flag is equal to 1. This is the transmit complete flag, and basically it just says when it's done sending everything. Okay, and it says this is required, for instance, when the USART is disabled or enters the halt mode to avoid corrupting the last transmission. So you shouldn't, try to stop or do anything like that until that transmit complete flag is done. Then if you wanted to, you could disable the USART. Okay, the receive process is pretty similar. You can see that, again, we've got to program these M bits, which we'll talk about, in the CR1 register to define the word length. We also have to select the desired baud rate, same thing. Of course, the send and receive should be set up to have the same baud rate, or it will be a problem. We again have to select the stop bits in the CR2 register. Now the difference basically comes here with step 4. We have to write the USART enable, in the CR1 register. That's exactly like before, but then we have to set the receive enable bit in the CR1 register. This enables the receiver, which then will start looking for that start bit. And then once we get data in, it will come into the receive data register, the RDR register. Okay, so let's look at these registers specifically to see what we're talking about. You see again, we have the 32 bits of the CR1 register, and we see the important ones that are there for us. You can see here's the word length. It is a 2-bit register, so we have 4 possibilities, but you can see the ones we would use are just 00, which says we have start bit, 8 data bits, and end stop bits. And remember, the N is because we haven't configured that part yet. That's a different one. 01, where we have 1 start bit, 9 data bits, end stop bits, and then 1 start bit, 7 data bits, and end stop bits for 10. So those are the 3 configurations. And notice that you have to do this, of course that's why it was in the list of the previous slide, before you enable the USART. So in other words, you have to tell it how you're going to send something before you enable it. And notice those bits are there for M1. So, and I guess really you should say and those bits here for the word length are there. Notice we have the parity control enabled. We talked about the parity control bit. That is right here. So if you're using parity, you'd have to enable that bit. The type of polarity that you're going to use, either even or odd, is right beside that bit here in bit 9. And then, of course, the others that we talked about, the transmit enable, the TE bit, where is that? That's right here. And it says, you know, this bit enables the transmitter. It is set and cleared by software. So if you want to enable it and start transmitting, you have to do that. Set that to a 1. On the other hand, if you wanted to receive, you have to set that bit to a 1, and that will cause it to start looking for the start bit. And notice we talked previously about how the start bit would bring the voltage low and so forth. Anyways, that is bit 2. And then just the UART enable bit, to enable it, you put a 1 in that bit, and that is here in bit 0. So this basically tells you the bits that are important. Obviously, you can see here is the oversampling. That's not in this slide particularly, but you can see this basically tells us the main ones that we have to look at when we want to use the UART, what we have to set up in the CR1 register. For the CR2 register, the only thing that we really had to talk about was, you can see there's lots of bits in here, but the main one we have to worry about is how many stop bits that we have. Because remember, over here it said in stop bits. Well, where do we choose the in? It's right here in stop 10. So notice that is right there in bits 12 and 13. So you can, determine if you want 1 stop, half stop bit, 2 stop bits, 1.5 stop bits, or so forth. And again, this field has to be written before you enable the UART. Okay, here's the last slide that I was going to really talk about in terms of the baud rate register. You can see what you have here in this particular thing is, depending on your oversampling that you choose, if you choose oversampling as 8, which is over 8 equals 0, or oversampling is 16, with over 8 being 0, or oversampling being by 8 with over 8 equals 1, and remember that's bit 15 over here. You have, obviously we talked from that formula how you use that formula to get BRR, but this is basically showing you different baud rates that you can get. And if you want those particular baud rates, what do you need to set the BRR register to? Now, please be aware, this is assuming the clock rate is 72 megahertz here. So obviously if you change it from that, then you would get different bit rates. But anyways, this is an important slide just to see how you would get the particular bit baud rate that you want, and what you would have to set the baud rate register to, depending on the oversampling choice that you make. Finally, let's look at the status register. We have a couple of basically flags here that are important to us. One is the transmission complete flag that we said would be set, and notice that is bit 6. And it basically, again, just as a reminder, transmission is complete when we get a 1 on that bit. It talks a little bit about interrupts here as well, but again, we're not using interrupts. So the other things that are important here in this register are the receive data register not empty and the transmit data register empty. So these 2 bits are basically here and here, right beside bit 6 for the transmit complete flag. And notice that it says for these, again, this bit is set by hardware when the content of the RDR shift register has been transferred into the RDR register. It is cleared by a read to the RDR register. And so basically that's saying when the data is read, it resets it. And it says when that is 1, the received data is ready to be read. Then when you read it, it resets it to 0, and then it starts, if you're still transmitting data, it starts to receive stuff into the shift register and then shifts it over again, and you can read it, and then it'll, reset that flag again, and so forth. The transmit data register empty, again, it says the data is transferred to the shift register when that's equal to 1. And so it says this bit is set by hardware when the content of the transmit data register has been transferred into the shift register. It is cleared by a write to the transmit data register. So when you write to the transmit data register, which basically is saying, hey, this is what data I want to send out, it does everything from there and will set the flags when everything is done appropriately. So notice that, these 3 registers, CR1, CR2, ISR, along with the transmit data register and the receive data register, which is where you receive the data, where you transmit the data and you receive the data, respectively, are the important ones to look at for the UART.
Alright, so this was supposed to be your lab 8, which is a UART lab, and in this lab you were required to have 2 boards on which one of those boards will act as a transmitter and another will act as a receiver. For now, I've set my left side of the board to be the transmitter and the right side of the board to be receiver, and this is how you should have hooked the pin. So the transmitter will transmit through the port A2 and the receiver side of the board will receive from the port A3. Now I've already loaded the program, and if I press here, if I press here, see, I've given B from the transmitter, so when I press here it gets B as well. Before there was nothing and now it's B. So how we can change it is, on the transmitter side of the code you have the transmitter data register. Here you give the hex value, and how would you know about the hex value is using the ASCII table. Like for this case I've given 42, which corresponds to B, so I get B on my screen. Now if I gave, instead of 42, I'll give it 41. So instead of 42, if I give it 41 and build it and load that, you can see here that before it was B. Now if I press here, it will give me A. So that was it. That was supposed to be your last lap.